Dave.
So this question is prompted by something that Noah said about illumination for Artemis 3. During a single EVA, the shadows that shift in the South Polar region will actually be smaller than they would in a day of field work on Earth. And you can, of course, do a whole mission in some areas in sunlight, but I'm constantly seeing the swirling shadows. Are you planning to land in shadows, or do you expect the normal EVAs outside of a PSR to be in shadows? What should we be expecting?
So we have requirements for the lighting conditions at the landing site, and we do expect it to be largely lit near the landing site. We are hopeful that there will be some amount of permanently shadowed area. Maybe it will probably be small within our walkable distance. We're gonna go to the coldest place we can find on Artemis 3. I don't know what exactly that's gonna look like, but we're gonna go our best. But for the most part, we expect our folks to be in relatively lit terrain.
Okay.
Yes.
Hi. Oh, I just gotta lower the microphone a bit. Should be fine. I'm Artash.
Can you give us your name and institution?
Yes. Hi, I'm Artash. I'm a high school student from Toronto, Canada. I research planetary and environmental science. I really enjoyed these presentations and learned a lot about the science objectives behind the mission and the new complexities that Artemis will face over the next decade. And I was curious. So the last lunar missions were over 50, 60 years ago. And back then, the missions had to rely on much less complex technology and processing power. And in the past, especially in the past decade, technology has leapfrogged and taken several big jumps. So I was wondering, what are some new technologies and techniques that Artemis will be using, either for sample analysis or to assist the astronauts on the moon that were not available to us back then?
I think Barbara come up and talk about the sample analysis component. Technologies, we're going to be using different communications approaches rather than what was used in Apollo. And obviously the technology of landing Starship is significantly different than what was used to land the LEM. I've tap danced enough, Barbara. Why don't you get into the sample part?
Yeah, for sample analysis for Artemis 3, you heard Renee say that we're not soliciting handheld instruments for Artemis 3, but that is something that we really, really, really want to infuse. We really want to have things like heads-up displays that overlay geochemical information on them so that while you're in the field, you can have a very data-rich view of your environment. That is something people like Matt Miller are working really hard to achieve. We don't have that for Artemis 3, but we really want that to be infused into the program. When the samples get back to the Earth, of course, we have the whole array of Earth-based technologies to bring to bear on those. And those sample analysis capabilities keep evolving, not only just because of the lunar samples, but because of all the samples that we get back, and particularly the very small samples from things like Hayabusa and OSIRIS-REx, Stardust. All of those techniques make us get smaller and smaller and focused and get more and more out of our samples. So that's a big difference from Apollo, where we had our techniques used a lot of sample, or comparatively to what we can do now with very small samples. So we're absolutely making use of the rich array of Earth-based technologies for small samples to get the most out of the more limited samples that we can get back compared to Apollo.
Hi, Carl Hibbett, JPL. I want to thank the last question that leads into where I was going, which is on future mission science planning and science operations question. I noticed some of the pictures are showing people looking at maps on the wall and pointing to computer screens. That reminded me not of the 70s, but of the 1990s. Here, to what extent are we going to be able to use virtual reality? Are you planning using VR and immersive environments and truly modern technologies like Oculus and things like that for real-time science analysis, science planning, interacting with the crew?
Yeah, thanks.
Yep.
So
Couple things to talk about here. So Barbara did mention heads up display. So I know not exactly VR, but I think relevant to your point here. There is a heads up display platform being developed inside of NASA. It's called Jarvis. Matthew Miller is heavily involved in that. I think Ben would be happy to take questions. I'd be happy to take questions about what that consists of. That would be used not for Artemis 3, but for future missions to help with crew heads up display. As for virtual reality, potentially for ground-based support teams, that's not currently critical path, certainly for Artemis 3. We're not evaluating the use of that in the SUR, for example. I will also say in the topic of kind of informatics to assist with real-time operations, again, not VR, but I think related to your question, the ops products that the crew will have for Artemis 3, real-time, visible to them, will be two things. One will be a cuff checklist like they currently have on ISS EVAs, exactly what you would imagine on the forearm. The other will be what we call a map book, which is essentially a fancy souped up binder of maps, derived data products, anything that the science team or the crew wants them to be able to see real time. The science team will be involved in populating that map book. So again, not fancy VR or AR, but we will be able to have a relationship with the crew to figure out exactly what's going to help them with real-time navigation and science objective completion.
Thank you.
Clyde, before we check in with you, can we check in with Ricky and see if there's any online questions? No online questions. Excellent. Okay, Clyde.
So you can't avoid me. All right. Clive Neal, University of Notre Dame. What a great time to be a lunatic. It's been said today, the young folks just listened to the gentleman that gave from a high school student. So this is an exciting time. And just to sort of paraphrase Jake, yeah, this is time to really be involved. So get involved. But that's not my question. My question is actually for Renee. So I hope she's still there. Renee talked a lot about LSEP and the passive seismic network lasted for almost 7 years when it was fully completed. And yet I saw the initial instruments have a lifetime of 3 months. Is that when the funding runs out and they have to be switched off, which is what happened with the LSEP? Or are there ways to keep monitoring stations if you're going to propose monitoring stations to keep those alive longer than 3 months?
Yeah, Clive, I think that's most
Looking
likely
around to
something
see
that
if-
can be. Can you hear me?
There she is.
Excellent.
Hey, can you hear me?
Yes.
Okay. Yes, the 3 months is what we have in there currently. And I think I can say that we would be able to consider on a case-by-case basis those efforts that think that they can operate for longer.
How would those requests be solicited, or is this an ad hoc? If you propose it, you do it in the initial proposal, or it has to be done afterwards?
Yeah, I don't want to contradict. I do believe that we put some type of guidance in the call about this, and I unfortunately am not able to recall it perfectly at the moment.
Me neither. So,
Yeah, so I'll follow up with you, Clive.
okay. Thanks very much.
I will say that as with all things, right, we're Artemis 3 is the starting place, right? And our capabilities are going to grow from there. No other questions? Okay. All right. We're good. All right. Thank you very much.